Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Veeam. My name is Cody, and welcome back to Techstrong Learning. Before we dive in, I have just a couple of housekeeping notes to review with you. First of all, we are recording our session today. So if you miss any of our conversation, if you'd like to watch again later, or if you'd like to share with the rest of your team, we'll be sure to send you an email with a link to watch the on-demand recording, and we'll do that shortly after we conclude this live session today. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. If you have specific questions, we do want you to direct those to the Q&A tab on the right side of that chat section. Sending your chats to that Q&A, or rather sending your questions to the Q&A, just helps us keep track of all of your questions. And we want to do our best to address them during our time. So please do send those into that Q&A box. Additionally, if you jump to that handout section, you'll see there is a link there for you. So feel free to take a look at that while you're here. And we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So ways to become eligible are to participate in our chat, submit questions, or you can fill out our post-webinar survey. We'll share a link to that at the end, but it's also in the handouts. So today's topic is Introduction to Kasten K10 and Kubernetes Data Protection. And I'm joined today by Florian Triloff, Kasten Senior Systems Engineer at Veeam Software. So Florian, thank you so much for joining us today on Techstrong Learning. Do you want to go ahead and take it over from here?
Yeah, Cody, thanks a lot for the introduction. As some people might have noticed, I'm not James Tate, who was announced in the invitation. He had another emergency topic he has to handle, and so I took over this topic for today about introduction of Kasten K10 and Kubernetes data protection. I'm doing the same like James is doing, so I'm specialized on all our Kubernetes stuff, all stuff about Kasten K10. I have a background on data center consulting, data center services, and so on. And so we will bring this together. We will bring the infrastructure, but also all the Kubernetes stuff together. First of all, we will talk a little bit about what's about Kubernetes, why should I take care about Kubernetes, and why do I still have all the topics around business continuity, about data protection, also in the Kubernetes world. We will have an overview of Kasten K10, how it will work, maybe also some infos about licensing, and some use cases. I think this is the most important topic here, talking about use cases, how to use this. Sure, we will also see some features. And we will have a demo scenario which brings together backup and some other topics here. Just to make clear, it's a recorded demo, and because of some time stuff and we shortened it a little bit, that we will have now around 40 minutes. And at the end, we will have a Q&A. Cody will moderate all the stuff. And please feel free to write your questions to the chat. So let's start into this demo, into this presentation here. So why are people thinking about backup, restore at all? Backup is simple, but data recovery, it's the most important part. Backup can run, nearly everyone can run a backup. A copy can be a backup, but the recovery, this is the most important part, especially if we talk about disaster recovery. Security. Encryption is good, but if I'm the one who has the encryption key, all good, and it's quite important. All topics about access control, auditing, ransomware protection, it's a big topic. And it's also a topic in a Kubernetes environment. And application mobility, there we will come back later here, so we will just skip this for the moment. But we'll have a look at some numbers here. So especially regarding ransomware attacks and attacks on infrastructure. And no one is saying, I'm now running Kubernetes. I'm fine. Everything's secure. No, it's just an infrastructure. It's just a server. It's a service somewhere. It's just hosting data, and it's business critical now. So outages and all the stuff. Yes, a lot of the stuff can be handled by Kubernetes itself, but we also have to take care about all the data here. So to sum this up, resilience is a big topic here. So a lot of companies are expanding to hybrid cloud workloads, have very time-consuming manual tasks, high risk on this. And this is a topic Veeam cares about. And now, as we are talking about Veeam and Kasten, it's one company. It's now one company which bring all the stuff together. But why should I have a look at this from a Kubernetes standpoint? A lot of people are saying, Kubernetes is just starting. We have just the first systems in place. We will have demo systems, demo environments, and so on. But we will see a lot, or we already see a lot of Kubernetes production usage. It's very, very fast growing, not just on the infrastructure side, but also on the development side. And it doesn't make a real difference from a business perspective if it's on-premise or on the cloud. There's no right or wrong here. So we have deployments, hybrid environments in on-premise and also in the cloud environments. And cloud-native development is growing, and it's growing and growing and growing. So enterprises take advantage of this speed and efficiency of, it's here in the slide that said cloud environments. But cloud can be also on-premise. It can be a public cloud, a private cloud, a hybrid cloud. So Kubernetes is now everywhere, and everyone want to integrate this into their systems. CI/CD pipelining automation, it's one of the biggest topics here, to automate everything, to improve the processes and also the products running here. And this is one reason why Veeam Software decided 3.5 years ago to board a company named Kasten.io. Kasten.io was founded 2017 and is completely focused on Kubernetes environments. And now we added this little part here, Kubernetes, to our Veeam data platform. But to make it clear, we are not talking about today about virtual machine backup, about infrastructure stuff. We are just talking about Kubernetes, nothing else here. And why are we talking about Kubernetes? A lot of people said, I'm running stateless. Kubernetes is great for my web shop, for my front end, for example. And I had a customer who just started their journey some years ago with Kubernetes. This was a big retail company. They decided, okay, we have to renew our infrastructure, and in our main business time, like Christmas or Easter, we have to scale. And now they decided, okay, we will run Kubernetes now for our front-end web servers. It's the easiest part. It's completely stateless. I just need some servers, some resources, also some cloud resources to expand their all the workload. Everything fine. Christmas season started. All good. All fine. Front end works perfect. No issues at all. But after some time, the database administrators came up and say, what are you doing here with our systems? We have never seen such a high load on our databases. What are you doing wrong? No, we don't do anything wrong. It's just we can now scale. And it looks like if you are not able to scale and if our front end is making a lot of trouble in your backend environment. Okay, now they decided, what should we do? They just decided that they will build up the whole infrastructure, and some parts are just able to lift and shift. Sorry, but they redesigned the whole infrastructure here, and they have gone this journey here. They started stateless, and they moved now to stateless applications and capabilities. Their databases now scale. So it's not a monolith anymore. It's just different databases. They are scaling over nodes. They can also scale into the cloud environments. And now they have a real stateful application. Okay, that's fine. The application runs fine. It's modernized, all good. But what will happen in case of something went wrong? A database upgrade failed. Volumes are damaged. Maybe just a logical error. Will this help in such an environment? So no, it will not help, because you can rebuild your Kubernetes from scratch if it is stateless. No problem at all. You go to your CI/CD pipelines, you deploy your application again, all good here. And but you need a way how to protect all this. So we will just have a look at what they ask us to how to handle this. And first of all, they said, okay, we have an IT department. They have backup tools in place. We can back up all virtual machines. We can back up all physical servers. Yeah, let's do this. Yeah, they did it. And they did a very, very good step. They decided not just to back up, but also to restore. And now they've seen, nope, there's no way to restore it. Because a VM level backup has nothing to do with Kubernetes at all. It's limited restore capabilities, so they can restore a Linux machine, but we have no consistency at all here. So, and it's very complex to bring all this together. The answer I love most, I built a script. I have someone in my company. It's okay. They export everything. They did everything with a script. All good. But it's tailored to an application and mostly tailored to one person. And it's very complex. It's often tied also to the infrastructure and very, very difficult to maintain. And then if we come from the other side, the storage handles everything. It will handle the storage, but nothing else. So it's a hard way now to restore or to integrate Kubernetes into a business continuity stuff. So now we talked a lot about Kubernetes challenges and so on. But what can be a different way how to interact with Kubernetes systems the real way? And that's why Kasten K10 comes into place. So we are just talking about Kubernetes native tools. Kasten K10 is a Kubernetes native application. It's fully integrated into the ecosystem of Kubernetes. Very easy to use. We will see this later. And also the security topic is very important. And I've just seen regarding security, there's just a question about security. I think Kasten K10 is open source, and that's not completely true. Kasten K10 itself is an enterprise application, but parts of Kasten K10 are open source. So, for example, our integration into databases, this is open source, but not the tool itself. but it's a completely native Kubernetes application based on container images and Helm charts. Yep, and I will come later also to the cyber attacks and compliance part. Okay, then as I said, Kasten K10 is now started 2017. We have a lot of versions and we release a major release 2 times a year. And we talked about also about native tools, native integrations. This was the first one we started, ecosystem innovations here. And the last 2 releases, I think, the most important parts were enterprise ransomware protection, scalability, because you might not have just one cluster, you might have a lot more clusters in your environment, scale everything, cloud security, and also all the self-service part here. But I won't go into details, but we will talk about the next step about use cases of Kasten K10. Because the use case is not just backup and restore, but we will start with backup and restore because it's the main functionality here. So what are we backing up? We are backing up applications running in a Kubernetes environment. So we will back a namespace, a project, name it like you want to. Technically, we are backing up Kubernetes objects, persistent volumes, and all objects related to a namespace, and also cluster scope resources here, which are a part of the application or which are just inside the cluster. So we are not backing up a control plane node or a worker node or virtual machine. I promised I will not talk about virtual machine backup. We are just protecting applications, the application way, and how an application should be protected here. And this we can back up, we can restore it in the same cluster, in another cluster, or in a completely different Kubernetes distribution. And this now comes to the part application mobility and disaster recovery. And at application mobility, we will have later a look at the demo environment here. So we will skip this for now, but we will have a look at disaster recovery and ransomware protection. What's about ransomware protection? Ransomware protection is about protecting your data, your applications in the right way. So using S3 as a target, for example, AWS S3, Azure immutability, or maybe on-premise S3 with immutability functionality will work, and we can use object log versioning to have a real copy of your application which runs inside your environment. You will now have this in your backup, and if something goes wrong or terribly wrong, you can restore this application with the state it had before. Another part is about not just about ransomware protection, it's about ransomware detection. We will have now an integration with different systems, advanced audit logs, Veeam systems. I will have an example later on this. So we are just using all the data we have, not just protecting an application, but also discovering, if, for example, a backup policy took much longer than expected. There's more data to be backed up, which indicates there's an issue, maybe for encryption or stuff like this. So you can take advantage of all these information and bring this together with your existing systems. But what about DR? What about disaster recovery here? And there are mostly 2 ways how to achieve DR and how to run a DR strategy with Kasten K10 in your Kubernetes environment. And there's nothing right or wrong. Both approaches are okay and can be used. And it's up to you and up to your business to decide which way is the best for which application. So first of all, we are talking about rebuild. We have a Kubernetes cluster in place. We have some databases, some applications there, doesn't matter. We have Kasten K10 in place. We back up everything to S3 or NFS, all good. And now your cluster crashes, or your connection crashes, or someone did something wrong, or something just happened. DR, cluster is away. So first of all, I need to rebuild a Kubernetes cluster. As I said, we don't back up the cluster itself. We are backing up applications or protecting applications here. So you have to rebuild, you have to recreate a cluster, hopefully automated. You will install Kasten K10 itself as a product, and you will run a K10 DR. It's a disaster recovery of K10 itself. Then K10 is up and running, and you can run a restore of all your applications, or just a selection of application with different restore points, with a mass restore. No problem at all. Your system is up and running. If you have enough time, that's great. You don't need any other resources. You just need a new Kubernetes environment, and maybe you can recycle some stuff which just failed before. All good. But if you don't have the time, you need another approach. And this is a so-called replicate approach. You will again have a Kubernetes system in place where your databases and all the stuff is running on. You have a backup, and now you have a second environment up and running. And on the first cluster, you have a backup policy. And on the second cluster, you will have an import policy. And this now will import in a scheduled way all your restore points and can restore your applications. So your applications are up and running in this DR environment. All good. It can be scaled down, for example. You can change everything doing restore, no problem at all. But you have a system which is up and running. And if now something failed, your network administrators and maybe some other guys on the infrastructure will have a lot of trouble. But your Kubernetes system is up and running with the latest state from the last import, and everything is there. Everything can be used. Maybe they have to switch some things in DNS, or maybe you have to scale up some deployments here. All good. But it's up and running. So it's very fast, but you need more resources and you need to operate much more environments here. And now you have enough time to build up a new system and to bring all this together in the state it was before. So have a DR again to another site, or maybe you can just migrate your applications to the other system. That's all about use cases, but now let's have a look at how we can deploy this and how we can use this tool. And there are different ways how to do this. Just a screenshot from our documentation. There are a lot of ways how to deploy Kasten. And it will run not just on AWS, Azure, cloud environments. You can run this on every Kubernetes distribution. You can use Helm to deploy our tool here. You can use Red Hat Marketplace, SUSE Venture Marketplace, AWS Marketplace from Container Anywhere, or a completely GitOps-based approach. You can just deploy our product inside your Kubernetes cluster. And there's no backup server. There's no proxy or stuff like this. You might know from other backup tools or classic backup tools. No, it's just a Kubernetes application running in your environment. And as it is now a Kubernetes application, you can interact with it in a Kubernetes native way. Everything we configure in Kasten K10 is a custom resource. Everything. You can use your GitOps tools for everything to configure Kasten K10. And that's great for automation, but you might have a namespace admin You might have other people in your organization where Kube API and kubectl and so on might not be the right tool for them. And that's the reason why you can configure everything in Kasten K10 also with a web-based dashboard. With integrated role-based access control, where you can give a namespace administrator the permissions to maybe restore their own application, but nothing else. So you can use this as an administrator, but also as a namespace admin, as a complete self-service. And for all of the people here which are aware of our classic backup product, Veeam Backup and Replication, for sure, there's now also an integration into this UI. You can see some stuff also there, but it's just an add-on. It's not necessary. You can use this in a complete Kubernetes environment, and you don't need anything else. It's just an option. But how does it work? Let's have a look at what are the 3 steps: discover, protect, and restore. We will discover everything what's inside this cluster. We will auto-discover all Kubernetes applications. We will run an inventory of all dependencies here. We include resource definitions, so custom resource definitions and all the stuff. Configuration and underlying data makes this visible here. And we can also integrate with databases here. We can discover databases and add a database-specific action here. So this will be everything auto-discovered in this infrastructure. Discovery is fine, but the first and important step is protect. Everything is a custom resource, as I said, and also a backup policy is a custom resource. So we will just backup this based on a custom resource. This resource will be created. Our controller manager will take care about it and will run all the actions needed here. And which actions these are, and also about the question about database limitations, size and type, and so on. I will come back in a few slides where we have a look at the I will come directly to this. So let's switch here. So we can just protect everything what's inside this cluster. So first of all, we connect to Kubernetes API. We will get all these Kubernetes objects, and we will run a data reduction here. So everything with deduplication, compression, encryption, and write everything to object and NFS. And that's fine for Kubernetes objects. As you can see here, we just talked also about stateful applications. And as you hopefully can see in the screenshot, we have just created a snapshot of a volume. So in this case, the first thing we are just creating a snapshot, and in the next step, we are exporting the snapshot, and doing export, we will run compression, deduplication, and encryption. It's a little bit a bad example here, because just snapshotting a volume of a database isn't the best way. So we interact with databases, and this integration is called Canister, and Canister blueprints are used for. We have a lot of examples in our documentation at docs.kasten.io, and also on the Canister project at GitHub. It's now a CNCF project now, or Canister part. You will have a lot of examples here. And these blueprints are open source. So you can just use these blueprints and maybe adapt some stuff here. You can tune these blueprints. And so, yes, we have examples, and they are also supported, what's on our documentation page, but you are free to add your own blueprints here. And regarding size limitations, it depends. If we are talking about, for example, a Postgres backup, where you can just use a command like pg start backup, you can set this database in backup mode, then you can create a snapshot and we can export the snapshot. We don't really care about the size of this volume because our data mover will scale, and you might just need some more CPU and RAM resources, but it's not a size limitation on this side. If you're talking about the MySQL database, where you don't have or not really have a backup mode, where you have to export this database, so there's no hard limitation for a size, but it might take some time to export a very big database here. So to sum this up, backups can be application aware, so integrated into databases. You will see more in the documentation, and I think we can also post this maybe later in the handout, or you will just find it in our documentation. Okay, so protect. Everything is now protected. Data is offsite at an S3 location. But now let's recover or restore. So also restore is a custom resource. You can run it through the UI. You can run transformations, for example, changing an ingress, deleting a host from a route, or just changing storage classes, scaling deployments, whatever you like to. And you can restore very granular, so you can select which objects you want to restore. You just want to restore a config map? All good, then just select the config map and we will just restore the config map. You want to restore everything to another namespace to make a copy, for example, you are fine. You might have a tool in place which just runs your deployment of your application. Just use it to deploy your application, and you can trigger Kasten K10 through Kubernetes API and run a data-only restore. That your volumes, which are, or the content of the volumes, which is not part of your pipeline, for sure, that K10 will restore just this. So it's up to you how to use it. You are free to use it the way you need to. And as I said, backup, restore, or discover, protect, and restore. It's important to have this as a basic. And there are some other outcomes here. So as I said, we have immutable backups in place. It's, I think, the most important part. If everything goes wrong, you have a place where it can't be deleted. And you can recover it in a very fast way. Because also our data mover runs multi-threaded. You just need a Kubernetes environment, nothing else. You don't need a special Kubernetes distribution. Maybe you don't have, maybe you have to switch a Kubernetes environment because you are running on-premise and you now have to run a DR in the cloud. It doesn't matter. It doesn't make a difference. It's just the same tool here. And why is this possible? This is possible because Kasten K10 runs inside your environment. It runs inside this, inside your cluster, inside its own namespace, and very important from a security standpoint, as I think this was the question, it runs without any root permissions. So we are just using Kubernetes API. You can audit everything, what this tool is doing here. And it runs without any daemon sets or stuff like that. It's just based on a Helm chart, and the outcome are some deployments. So, and also about infrastructure, as I said, we are using the Kubernetes API for everything. So there's no proprietary storage layer or stuff like this. We can just interact with CSI drivers, for example, with cloud environments and so on. And we can now export everything to S3 or NFS. And therefore, we will have a look at how this will work in our demo here. So we have one Kubernetes cluster up and running. It's just a source a source cluster with an application, with some services, with K10. We will create a snapshot. We will create an export to a S3 location. And then we will build up an OpenShift system. We will just deploy it in the cloud. It's a ROSA system. And and this system will now start. We will run K10 there, and we will run a restore there. And this we will have a look at the demo now. So we will run a cross-cluster app mobility with Kasten K10. We have a Kubernetes native application. It's a microservice-based application. It's a sock shop, and we have this on-premise running in an environment here. So not completely on-premise, but mostly. And it's running on-premise, and we want to restore it in a Kubernetes, another OpenShift environment. So we will just create a new cluster on ROSA, here on AWS. We will just add all this here. We will just deploy a new cluster from scratch. This can all be done via CLI. So it's just better to show something than just pasting all the commands here. This will install in the backend now because it will need some time. And we will now go to our source system. We create a backup policy, the sock shop migration, set this on demand, and we want to export this backup to an immutable S3 storage. Just selecting the application here, create, validate, run this policy manually. So now this policy will start. And as you have seen on the screenshot, it will just create a backup action and an export action. We have 6 snapshots of 6 volumes, some specs here, some exports here. It took in real life 5 minutes, so quite fast for some data here. And also now our OpenShift system is now up and running, the new one on AWS. Just log in. And we go now to the operator hub. As I said, it's one option how to deploy an application there. We'll just install Kasten K10 in this environment. It's all based on an operator. And now it will deploy. The operator will start, and we can now create a new instance here. Just enable basic authentication. You can integrate this with OEDC, Active Directory, and so on. But for now, it's the easiest way to use. I think it's token authentication we used here. And the deployment is now starting. Hopefully, we will have a route now. And we connect to Kasten K10, use our token, and we are here. This is K10, the new system on the target side. So we will just add our Amazon S3 storage account here. So access key, secret key, bucket, region, and it's the same as we have on our source cluster. Enable immutability, all checks fine. Save profile, we validate everything, and now we have a connection to our backup target. And as these are 2 separate installations, we now have to import the restore point metadata here. And as everything is encrypted, encryption is based on a policy level, we will just pasting the encryption key here, select the source, and we will just now import all this stuff here, what is related to this application. Importing restore points took 15 seconds. And now we can go to our applications, and there's no sock shop. For sure, because it's not there. We just imported the metadata, and we will now run a restore of this application here. We'll just create a new namespace on this target system, and we have to transform some stuff here. We have to transform the storage class because on our source environment, there's another storage class here, and we have to replace this value, storage class with GP2 CSI. I think the source one was the vSphere one, and yeah, vSphere CSI. And now we store this to a GP2 volume. And the second thing, we have to remove the route host because it sticks to the source system. We will have this on the target system. So we will just remove this spec, this host here. And so it was the on-premise one. It will be removed and auto-generated while it will be restored. And additionally, we will deselect our storage class because we don't need vSphere CSI storage class in an AWS environment. Makes sense. And now our restore will start. We can just go to the pods of our new application. So we'll start some affinity pods because of the volumes we need to restore. We are restoring the data. All the pods will now start. Data is restored and our sock shop is completely online again. We will go to the route here and yeah, our shop is now online. We can log in to the shop. We will have hopefully everything in place here. We have all our accounts. We can now use it in a cloud environment. We can scale it. And yeah, we have now an application running not just on premise, but also in a cloud environment here. And yeah, this brings together all the use cases. So we did a backup, a restore, a migration, and it can maybe also automate it. As you have seen, you can schedule imports, that it is also possible to just run this automatically. So maybe not for a shop, or maybe also for a shop. It depends on your use case here. You don't stick to one use case. You can use it with a lot of tools here. And yeah, as this is a Red Hat, it was a Red Hat system, but we don't stick to a Red Hat environment. It can be anything else. So we are not taking care about the management of a Kubernetes cluster itself. There are tools in place. They can be named Red Hat Advanced Cluster Management. It can be SUSE Venture. It can be AWS. It can be anything. And yeah, we don't take care about this, but we take care about all the backup, migration, and all the data stuff inside your environment. We are taking care about business continuity, and we are added on to all these Kubernetes systems here. There's one special thing about Red Hat today. You might have seen this at one slide here. You can now run virtual machines on Red Hat OpenShift. It's called KubeVirt or Red Hat OpenShift Virtualization. And we can also protect these VMs running on Kubernetes. And I'm not completely sure. I said at the beginning we don't talk about VM backup, but this is one option you can use today. It's fully supported to backup and restore a virtual machine on OpenShift. At other virtualizations on Kubernetes systems, we are working at the moment. So I think OpenShift is just the beginning, but we can also protect this one here. To sum this up, we talked about Kubernetes data protection. And we talked about this from an application standpoint. So we are talking about data services running there. It can be stateless, it can be stateful, it doesn't matter. We will protect everything what's there. And you can decide what you want to back up here. For example, I see there's one question about persistent general storage every time. So you can, if you want to back up an environment here, the question just dropped. Okay. Okay. So it just shifted here. So if you back up this data service, as I said, we are running compression, deduplication, encryption, and if you decide to schedule this every hour, we will read all the data, but we will have an incremental forever here, so we don't back up the whole size every time, but just the first one, and everything else will be incremental backups here. So about Kubernetes distributions. So we just need a Kubernetes environment. And please have a look at one page in our documentation where we qualify Kubernetes versions. It's the only important thing. It can be any Kubernetes, but please keep an eye on our documentation and release notes about supported versions here. We are supporting a lot of versions, and but it doesn't matter which Kubernetes distribution. Same from the storage side. If the CSI driver is in place and is up and running, if the snapshotter is running, everything fine, and that's good. We don't qualify, or don't really qualify storage systems. We have a list of storage systems which we see in the market very often, but we don't have a real qualification process, because if it's running in Kubernetes, then it's fine. And I think about deployments, there was another question in the chat. Does K10 free version have a time and size limit? Yeah, you might already have seen the link here. You can install Kasten K10 directly from our Helm repository. You can run thanks a lot. And you can run just it in your environment. The free version is limited only by the number of Kubernetes worker nodes, because our licensing model is based on the number of Kubernetes worker nodes which are in the cluster where Kasten K10 is installed. So if you have, for example, if you have an OpenShift cluster with 3 control plane nodes, 3 infra nodes, and 10 worker nodes, you have to license 10 worker nodes. And our free license is not feature limited, but this license is limited to 5 worker nodes here. So no time limit, but just a size limit on the number of nodes. Hopefully I answered all these questions here. Okay. That's about the deployment, the Kubernetes distribution, and the infrastructure here. But again, a security topic. A lot of people today operating Kubernetes environments have policy management tools in place, like Kyverno, Open Policy Agent, or stuff like this. They can integrate with us. We have customers which has a policy that every application which is production relevant has a special label called production. And Kyverno now is responsible for to make sure that everything is based, that everything is in a backup policy. So Kyverno will check if there's a backup policy in place, if this backup policy is scheduled, and if everything is fine, and then this application will be deployed. So it can be really integrated with all these tools. The same with key management, HashiCorp Vault, AWS KMS can be connected with Kasten K10 for all the key management. If you don't have a key management, no problem at all. It will stay all inside Kasten K10. Kasten K10 has a backup functionality of itself. So it can be also restore everything what's configured here. So you don't have to care about. But if you want to use this another way, you can just connect HashiCorp Vault or AWS KMS. That's all here. Okay, just for the questions. If we look what happened in the last release. there was one very important topic, or some very important topics especially about public sector. Our container images are built the best way we can build them. They are checked for vulnerabilities and so on. But for some people, this is not enough. So we have now all our images also on Iron Bank. It's very public in the US, but also UK and also some parts now of some other parts of EMEA are working together with Iron Bank, where it's a hardened image registry where all our images are there. And as I said, virtual machines on Kubernetes and scaling a lot with a lot of clusters. So to have some maximum numbers, we have one customer with 60 petabytes of data in their Kubernetes environment. And they're using K10 to back up this and also to restore this. For sure, it will take some time, but it's the tuning parameters are just a few. So a lot of the stuff worked out of the box. The same with clusters. We have a customer with about 500 and more worker nodes for different clusters. They bring all this together. They have K10 there. We have also a multi-cluster dashboard, which I haven't showed today. So it can scale in your environment. It's not a niche product for just some small clusters. It is an enterprise product which can scale and handle such environments. And as I said, security is a very, very big topic. And I think I already said this, that we have also now integrations with an extended audit log backend, and we can extend all the visibility for all the DevSecOps teams across all applications about all data. They can bring all data together. Like if someone is trying to delete a backup or someone is running a mass deletion of backups, it can be a security incident, but it can be also normal. We can't decide from our side because we don't have enough data here. So this is the reason why we give all this information to Veeam systems like Datadog. It's just an example. And we can bring all this together in, and you can take advantage of all the data we might also provide here from a backup standpoint. So we are a part of the business continuity process. We are integrated completely into all these environments here. And we are Kubernetes native, but as you have seen, you can use the UI, everything. So someone who is not so skilled in Kubernetes, hey, just use the UI and be fine, and you can handle your environment the way you need to handle it. And for this, I'm now nearly at the end of our session today. I really hope it was helpful for you. You hopefully have learned something, and you might have something to try to just use it in your test system, in your demo system, or stuff like this. And if there are some other questions, we'll just have a look at the chat and the Q&A. So Kobe, is there anything coming up?
So it looks like we've only got 2 questions remaining at this point. So if anyone in our audience has any more questions, now is the final call. But let's start off with this one. How can I test this? And is there an easy way to get started?
Yeah. So the easiest way how to get started is that you just use this link here, or Kasten.io, free Kubernetes, or you go just to our documentations, docs.kasten.io. There you will find our documentation. There you will find a way how to install Kasten K10. As I said, it's a Helm deployment. You can just follow this one here, and you will also find on our learning platform. It's called Kube Campus. This Kube Campus platform will have a lot of hands-on training, not just on Kasten, but also on Kubernetes, where you can get the first a first look and feel about this without installing it in your environment here.
Perfect. Thank you. Thank you for that. And for anyone who maybe isn't into QR codes, we've also got this included in the handout, so feel free to click over there as well.
That's great.
So it looks like right now our final question is, are there database limitations as far as size and type that we should know before we get started?
So about database as something to back up, it depends on what your database is running here. So we can just have a look at. I will just have a look at one site, Canister GitHub. I will just bring this up here. Okay, that's all good. Just go here. We have a lot of database examples here. As I said, we are talking about also external databases we can back up here. We are talking about Elastic, Foundation, K10, MariaDB, Mongo, Postgres, and so on. And these are there out of the box. So there's no limitation on this side. And as you can see, these are all just opening the MySQL blueprint here. It's all just a Kubernetes resource. You can modify everything. You can change everything. You can change what's going on. You can, for example, MySQL dump, you can just tune these parameters. So there's it's up to you. Per default, everything is running here in this environment. So if you, I will just open another browser here, bring this up again. If you go to our page, you can go to have a lot of examples here, end-to-end examples for everything what's supported here, but it's up to you. There's no real limitation from a data mover standpoint or stuff like this.
All right. Well, Florian, it looks like we are at the end of our hour and we've tackled every question that we've received. So I appreciate you jumping on those as you went through your slides today. But before we close out, I do just want to give you the opportunity to leave us with any parting thoughts or any key takeaways before we take things off the air.
So I think the main key takeaway should be that there's no reason why you should not take care about your infrastructure and your data, even if it is Kubernetes. Kubernetes is great for a lot of stuff and it really worked well, but it's no excuse for not having a DR strategy, for not having business continuity models, and it's in production. Maybe not in your main in your main data center, maybe not, but in the development part and also some other parts of your company, it's state of the art today, and it should be included into your protection strategy for your company and to make a company successful, even if something happens. And it's not the questions when there will be an attack. The question is just when and how to fight against this and how to come back. I think this is the most important part to think about it. And now you have an idea of a tool which can help you on your journey to bring this into real production.
Well, Florian, thank you so much for joining us today. It's been such a pleasure speaking with you and learning all the intricacies of Kasten and Veeam with you today. So thank you so much for your time.
You're welcome. Thanks a lot. And thanks a lot for all the people here in this meeting and the great questions. I appreciate it.
Of course. So before I dismiss our attendees, just stick around for one more second. I've got a couple closing thoughts. Today's session was recorded and we'll be sure to send it to you via email here shortly. But you can also find it living on the Cloud Native Now website. That's cloudnativenow.com/webinars. Thank you so much for your chats and questions. If you wouldn't mind filling out our survey that is pinned to the top of the chat, we would love to hear your feedback about our program today. And doing so will also make you eligible for our $50 Amazon gift card giveaway. So don't miss out on your chance to win that card. So I'd like to thank Veeam for sponsoring our program today, and to everyone in attendance, thank you so much for being here. We appreciate and value your time, and we hope to see you at a future Techstrong Learning Experience. Have a great rest of your day, and you may now disconnect. Thanks again, Florian. It's been a lot of fun.
Thank you.